Hello, this video will be a technical overview of smart transactions and colored coins on Chia. To start with, we're going to be looking at ChiaLisp and how it relates to puzzles. To start off, let's remind ourselves what a coin actually is. It simply holds three pieces of information: a parent ID, a puzzle hash, and an amount. The puzzle hash is the commitment to a ChiaLisp program which controls what happens when the coin is spent. ChiaLisp programs can be modeled as trees, so the puzzle hash is the Merkle root of that program. We only need to store the hash because we reveal the full puzzle when we spend the coin. Now, to expand a bit on what I mean when I say the puzzles control the behavior during a spend, let's look at what's actually happening. So I'm going to give you a demonstration using the CLVM tools repository. This is public on GitHub and you can play along at home if you'd like. So here is the puzzle that's locking up a coin. You can see it checks if the first thing in the solution is equal to 100, and if so, it will return success, and if not, it will fail. The X means it will fail out with the error not 100. So if we put in 100, we get success. If we put in any other value, we'll get a CLVM raise, and this means that the spend was not successful. So remember that the puzzle is locked up in a hash, so we reveal the full puzzle source code and then attach a solution, which in the example I just gave would be 100. We can also include a signature as well if we'd like. We have defined opcodes that allow a ChiaLisp program that doesn't fail to communicate with the blockchain. These opcodes are either this transaction is only valid if X, or if this transaction is valid, then do X. Here is our actual list of opcodes. Aggregated signature checks that there is a signature for a value from a particular key. Create coin will create a new coin with a given puzzle hash and amount. Assert coin consumed checks that a coin specified has been consumed to this block. Assert my coin ID asserts that your coin ID is the hash given. And then some ones related to timing, another one related to the signatures attached, and one that talks about the fee. And these conditions should be returned as a list to the blockchain network. So to fix our example from before, we should make it look like this. So I've changed the success condition to say if it succeeds, create a new coin, 51 is for create coin, with the puzzle hash dead beef and amount 200. So the coin that we spend will create a new coin, and we don't need to specify a parent because the parent is the coin we just spent. It's important to remember that anyone can attempt to spend a coin. As long as they can reveal the correct puzzle, anyone can suggest a solution. So how does coin ownership work then? We simply use the agsig condition to assert that the spend has been authorized by our private key. So we've got a puzzle here that means that we always have to have a signature from the corresponding private key for the public key faded dab of the string example, and then any conditions that are in the solution will get forwarded straight on. So we're going to give it the example of creating a new coin with the puzzle hash cafe food and amount 3. So this will return to the network. We need a signature of example from the public key faded dab, and then create the coin because this is what the solution told it to do. We go further into detail on CLVM and the ChiaLisp language in our written guide. If you want to know more, check that out. Before we move on, I would like to clarify that we do have a higher level language which is more expressive, allows for function definitions, and has higher level operators. This higher level language compiles down to CLVM, which is what locks up the coins and what runs on the network. If you want to learn more about how CLVM and the higher level ChiaLisp language are working, Make sure to check out CLVM tools and the documentation there. This concludes part 1 of the technical guide on smart transactions and coloured coins. In the next part we'll go more into depth on how coloured coins are working specifically.